Welcome to the Cosmic Frontier, where today we embark on an extraordinary journey beyond the stars and galaxies. We're diving into the enigmatic realm of the universe's dark ages, a period shrouded in mystery with the help of the groundbreaking Webb Telescope. This incredible instrument promises to peel back the layers of time, offering us a glimpse into the very dawn of the cosmos. So, fasten your seatbelts and let's explore the cosmic mysteries that have puzzled scientists for centuries. Are you ready to unlock the secrets of the universe? Let's begin. A period of total obscurity once pervaded the universe, an epoch devoid of stars or galaxies to light up what we now recognize as our cosmos. However, the question lingers, did this dark epoch truly exist? The James Webb Space Telescope is set to demystify this enigmatic period for us. For the first time, we have the capability to visually explore an age believed to be absent of light. Utilizing advanced computer technologies, scientists have meticulously reconstructed the young, fiery universe's events with remarkable precision, and for a while, everything appeared to align seamlessly. Yet, the revelations from James Webb have turned our understanding on its head, presenting us with phenomena during the dark era that, by all accounts, should not exist. Let's delve deeper into a universe mystery that, until now, was scarcely understood or integrated into astronomers' calculations. Referred to as the Dark Ages, this period spanned from the immediate aftermath of the Big Bang to the genesis of the initial light sources. For ages, astronomers could merely theorize about the occurrences of this era. It is believed that towards the close of the Dark Ages, the universe's earliest stars and galaxies began to take shape, including the massive luminous blue stars of population III. Supergiants, after living for a few 100,000 years, erupted in colossal explosions, paving the way for a new generation of stars and elements with their mighty force. Up to this point, everything aligned with our understanding. However, with the 2022 summer launch of the James Webb Space Telescope, we began to peel back the layers of this obscure era, revealing astounding sights. Contrary to expectations, James Webb has unveiled galaxies ablaze with light in a period previously thought to be engulfed in darkness. As we venture into the dark epoch of the universe, which commenced roughly 380,000 years post-Big Bang and continued until the birth of the first stars and galaxies, we're taken on a speculative journey. Until recently, scientists were convinced these formations occurred around 1 billion years after the Big Bang, based on studies of the cosmic microwave background radiation, essentially the Big Bang's afterglow. This epoch earned its dark moniker due to the absence of light sources. The universe's first stars were yet to be born, and a thick hydrogen gas fog permeated space, blocking any light. Imagining this epoch, one would envision an utterly dark space where hydrogen and helium gases expand, resembling an ocean, with the swirling gases displaying subtle temperature fluctuations. Variations in temperature and density gradually evolved into the forces responsible for the creation of stars and galaxies. As the universe cooled down over time, it set the stage for the emergence of the first complex structures. During this period, particles like neutrinos and dark matter darted through space, with the latter speculated to have significantly influenced the formation of the cosmos's earliest structures. Gas coalesced around so-called gravitational nuclei, which started to oscillate and eventually led to the birth of the initial stars, known to researchers as population III stars. The powerful radiation emitted by these blue supergiants gradually ionized the dense surrounding hydrogen gas clouds, making the universe more transparent to light. This transition, known as reionization, marked profound changes and effectively concluded the Dark Ages. We traditionally place this milestone at about 1 billion years after the Big Bang, but the James Webb Space Telescope has provided evidence of fully formed galaxies existing just 300 million years post-Big Bang. These early universe anomalies, the so-called cosmic rule breakers, seem peculiar, but a few galaxies have begun to challenge our previous conceptions of the universe's infancy. James Webb's groundbreaking discoveries are reshaping our understanding of these formative epochs. This remarkable find was aptly nicknamed universe breakers. These ancient galaxies aren't defying the laws of the actual universe. Rather, they're sweeping away long-held theories about the origins of space and shattering conventional wisdom. Remarkably, the oldest among these galaxies were ablaze during what is commonly referred to as the Dark Ages, compelling scientists to seek new explanations. Furthermore, the telescope has uncovered early black holes, including one that, by all existing physics laws, appears to be older than the universe itself, just 500 million years after the Big Bang. This colossal entity was so massive, it could contain 1 billion suns. This presents a conundrum. How did this black hole amass a billion solar masses just 500 million years after the Big Bang, especially when stars were thought not to exist yet? This black hole isn't an isolated phenomenon, but rather sits at the heart of a massive, advanced galaxy. This revelation leads us to another universe-altering discovery: black holes at the centers of galaxies, which were previously seen as hallmarks of ancient and evolved galaxies, challenge our understanding once again. Yet such phenomena were not expected in the universe's youth. The James Webb Space Telescope demonstrates that the timing and processes within the universe were vastly different from what was previously believed. Indeed, James Webb has revolutionized our understanding. This telescope has truly made a significant impact. Interestingly, and somewhat amusingly, the dark epoch of the universe was once deemed invisible, attributed to the complete absence of light. However, we can now observe this era firsthand and are astonished to find that the Dark Ages were neither dark nor devoid of galaxies. Launched as part of an international collaboration involving NASA, ESA, and CSA, the James Webb Space Telescope aimed to bring us as close as possible to the inception of the universe's first stars. For scientists eagerly anticipating the observation of the massive nascent population III stars, the galaxies unveiled by James Webb came as an astonishing revelation. These discoveries have plunged astronomers into a realm of new challenges, heralding the dawn of a new era in astronomy. Ultimately, James Webb sought to elucidate the formation of the universe's first stars and galaxies. Now it's clear we must delve even further back in time to truly understand these origins. This insight challenges our previous notions of the Big Bang, 13.8 billion years ago, and the subsequent Dark Ages, compelling us to rethink our understanding of cosmic history. The theory of the Big Bang and the concept of the Dark Ages were not concocted from mere speculation. They are grounded in substantial observational evidence and have undergone rigorous testing. For a long time, the cosmic microwave background radiation, which maps the early universe's structure like a detailed tapestry, served as a key piece of evidence, suggesting that the universe originated from a singular event known as the Big Bang. However, as research progressed, the foundational observations increasingly relied on assumptions and complex variables like dark matter, the existence of which remains unverified and may be at the heart of the discrepancies. The Big Bang theory is indeed facing scrutiny, yet scientists are not prepared to abandon it entirely. A recent hypothesis has proposed adjusting the universe's age to 16.7 billion years, although this has yet to be universally accepted. Despite the latest discoveries, most cosmologists specializing in the study of the universe's youth still believe that the Big Bang and the notion of cosmic expansion hold up as fundamentally sound theories. Another potential resolution to align with older models is the idea that stars and galaxies formed much more rapidly than we had previously thought, though this adjustment poses its own set of challenges. Considering it a remarkable feat of physics, we can't dismiss the theory that the Big Bang might have happened between 40 to 100 billion years ago. There are also suggestions that our initial interpretations of redshift, which researchers use to measure the distance and motion direction in the universe using old, well-traveled light waves, may have been incorrect. Even the slightest inaccuracies in these measurements can lead to significant errors. It's plausible that a dark age existed, but further back in time than we previously thought. The challenge now is for researchers to either develop a cohesive new explanation, pinpointing where our understanding has faltered, or to wait for the development of more advanced telescopes capable of looking even further back in time. How far can the James Webb Space Telescope see? It's important to note that, until recently, scientists believed our vision could only extend back to about 500 million years after the Big Bang, as it was assumed there was no light before this point. This perspective allowed us to look 13.5 billion years back in time. The Hubble Space Telescope theoretically had the capability to see this far, yet it provided only very blurry images from this epoch. The James Webb Space Telescope's official range also reaches back 13.5 billion years, but it was anticipated that this new instrument would produce much clearer images. Thanks to its advanced technology, James Webb can dissect the faintest light signals into their component parts, enabling us to analyze previously blurred light spots with unprecedented precision. Utilizing the Hubble Space Telescope, even at these vast distances, researchers have discovered galaxies that are 6 billion years old and possibly even older. This finding suggests that the James Webb Space Telescope's actual observational capacity extends much further. With some adjustments, we might be able to observe galaxies that are 13.8 billion years old or more. Such discoveries could confirm that the Big Bang didn't occur at the time previously believed. Regarding new theories, there are already several intriguing propositions about the early universe's true nature. One theory suggests that the formation of stars and galaxies began much earlier than we thought, indicating a more rapid aggregation of matter in the universe's infancy. Essentially, this would mean a quicker genesis, where gas and dust came together more swiftly to form the initial stars and galaxies. It's possible that an unseen component or an overlooked force played a pivotal role in spurring on star formation, thus speeding up the process even more. Other theories highlight dark matter's influence and propose that variations in the early universe's density could have led to quicker than anticipated gravitational collapses. In the realm of theoretical physics, the concept of a predecessor universe has been introduced to account for some of the more puzzling discoveries. British physicist Sir Roger Penrose proposed the cyclical universe theory in 2005, suggesting that each universe's demise paves the way for the birth of a new one. This notion could also shed light on the enigma of black holes existing before the formation of the first stars. Advances in particle physics and quantum gravity theories could offer crucial insights. Imagine a scenario where exotic particles act as catalysts for the swift emergence of structures and matter in the nascent cosmos, or where the quantum foam facilitates the rapid growth of matter in the young universe through previously undiscovered quantum mechanics principles. Turning to NSA, there's much curiosity about what the agency might be keeping under wraps. Today, we delve into the greatest NASA mysteries, focusing on the agency's reticence regarding alien life and extraterrestrial activity within our solar system. Persistent rumors and speculation surround NASA projects, especially when findings are perceived as not being fully disclosed to the public. This lack of transparency only adds fuel to the speculative fire, particularly given the United States' leadership position in space exploration. In the arenas of global politics, business, and surveillance, NASA stands out as the preeminent authority in space exploration and travel. Owing to its long-standing monopoly in this field, there are allegations of extensive secrecy and concealment within the organization. Some critics argue that NASA has implemented a strict policy of silence and denial to hide groundbreaking discoveries. The intrigue surrounding Mars raises questions about what we truly know. Would it surprise you to learn there might be life on Mars, and that NASA could be aware of it? Speculation about extraterrestrial life on the Red Planet has been rampant for over a century. Despite sending numerous probes and rovers for exploration, no definitive evidence of life has been publicly acknowledged. Yet, Rumors continue to circulate about the potential past presence of life on Mars, fueled by online images claiming to show remnants of buildings, Stonehenge-like structures, or pyramids. Typically, NASA officials either refute these claims or abstain from commenting. Officially, NASA's mission includes the search for life on Mars, which has led to several rover landings on the planet's surface. In regions that seem to have once contained water, NASA's rovers have advanced to the point where they can bore into the Martian surface to collect and analyze rock samples. Yet, no trace of bacteria or any microorganism has been detected to date. NASA has declared Mars to be biologically inactive, but the planet's methane emissions tell a potentially different story. On Earth, methane is commonly linked to biological processes produced by a wide range of life forms, from cattle to bacteria in wetlands. Methane on Mars has been identified by instruments like the tunable laser spectrometer aboard the Curiosity rover. The seasonal fluctuation in these emissions hints that the methane could be generated by geological activities affected by temperature changes, or possibly by an unidentified biological source that aligns with Martian seasons. Speculation and some evidence suggest that Martian water might have seeped below the surface. While NASA dismisses the notion of subterranean cities or vast oceans as fanciful, it remains conceivable that Mars's deeper strata might be damp and could support simple organisms. An alternative, less thrilling explanation for the methane traces, one that doesn't invoke microbial life, involves the chemical reaction of water with certain Martian minerals. Another hypothesis posits that the detected methane might originate from ancient microbial life, preserved within Martian permafrost, which occasionally thaws, releasing the gas. Computer models have repeatedly suggested the historical presence of oceans on Mars, with the planet likely losing its sparse atmosphere early in its history, diminishing its capacity to retain liquid water on its surface. If Mars once harbored water, it's plausible that simple life forms might have existed. The current state of such life and the feasibility of revitalizing Mars into a habitable planet through terraforming remain uncertain. Elon Musk's proposals for terraforming Mars were initially met with skepticism, labeled as overly ambitious. Yet, few are aware that NASA had entertained similar terraforming concepts in the 1990s, which were eventually shelved due to doubts over their viability or the prohibitive costs involved. The source of the mysterious "wow" signal continues to pique curiosity. In the dynamic field of space exploration, it's noteworthy that NASA isn't the sole entity pursuing the mysteries of the cosmos. The SET, I Search for Extraterrestrial Intelligence project, initiated by independent radio astronomers, now employs the world's largest radio telescopes to scan the cosmos. This initiative is dedicated to monitoring space continuously, sifting through every unusual sound detected. While these sounds are not audible in the traditional sense, sensors capture the data, which is then analyzed for any irregularities by both computers and volunteers globally. On August 15, 1977, an extraordinarily strong radio signal was detected by the Big Ear Radio Telescope at Ohio State University. Originating from the direction of the Sagittarius constellation, this signal persisted for 72 seconds. The astronomer, Jerry R. Effman, upon reviewing the data, was so astonished that he wrote "wow" next to the printout, hence the signal's name. Despite many efforts, this signal has never been replicated or explained, fueling theories about its extraterrestrial origins. Another intriguing instance is the BLC-1 signal, detected by the Parkes Telescope in Australia as part of the Breakthrough Listen project. Interestingly, this signal originated from the vicinity of Proxima Centauri, our closest stellar neighbor, where an exoplanet resides within the habitable zone. An Earth-like exoplanet in proximity has made the BLC-1 signal particularly intriguing, leading some SATI experts to deem it a significant find, potentially indicative of intelligent origins. However, more cautious scientists and NASA have suggested that BLC-1 might stem from terrestrial interference. Like the WOW signal, the precise source of BLC-1 remains unidentified. This mystery inspired billionaire Yuri Milner, a fervent supporter of SETI efforts, to donate substantial funds towards the Breakthrough Starshot initiative. This ambitious project involves constructing miniature spacecraft, designed by some of the world's leading engineers, to be propelled at near-light speeds towards the Proxima Centauri system for closer investigation. The notion that space might have been shaped by an intelligent entity or could possess intelligence itself remains a contentious topic far from being acknowledged by NASA. Yet, upon examining the universe more closely, the presence of precise geometric shapes across the cosmos raises intriguing questions. These patterns challenge the perception of the universe as merely a chaotic amalgamation of mathematical equations and randomness, prompting us to ponder the underlying principles that govern its structure. The hexagon on Saturn's North Pole, extensively studied by NASA's Cassini spacecraft, presents a particularly captivating phenomenon. Spanning wider than 2 Earths, this atmospheric hexagonal pattern has piqued scientific curiosity. Cassini's observations revealed intriguing aspects, such as indications of a blue sky at the hexagon's center, suggesting the possibility of unknown atmospheric layers beneath Saturn's dense gas clouds. While the existence of life or an advanced civilization on Saturn seems highly improbable due to the planet's extreme pressure conditions, which are inhospitable to life as we understand it, some intriguing claims emerged in the 1980 as in 90 CIs. Welcome to Blessovia Science TV, where we take you on an exhilarating journey through the cosmos and unravel the mysteries of science. We are excited to offer you the opportunity to become a valued member of our ever-growing community of cosmic enthusiasts and knowledge seekers. Exclusive access to cosmic content. As a member of Blessovia Science TV, you will gain exclusive access to a treasure trove of cosmic content, including documentaries, interviews with leading scientists, space missions updates, and awe-inspiring visualizations of the universe, live Q, and sessions with experts. Your membership will grant you the chance to participate in live Q and sessions with renowned scientists, astronomers, and space explorers. Get your burning questions answered by those who push the boundaries of human knowledge. Embark on a journey that spans the cosmos and join us in unraveling the secrets of the universe. Become a Blessovia Science TV member today, and together we will reach for the stars. Thanks for watching. Subscribe, like, and share. Don't forget to leave your comment.